So configuring frame relay subinterface. In frame relay we can create two types of subinterface. One is point to point, another one is multi-point. In point to point interface we can create separate interface, that means lease lines means point to point connection. For example, here we can have three routers. We can see that here in this topologies we have 4 routers. This is an head office. Router 5 is an head office. Router 2, 4, 3 is an branch office. Here we can give point to point interface, means we can create only one. That physical interface can be created into sub interface. For example, this is an serial 0/0/0. So 0/0/0.1 is an one network, 0.2 is another network, and 0.3 is another network. So each network we can use separate IP address. Each point to point sub interface requires own subnet, that is separate net ID, and point to point is applicable to hub and spoke topologies. Previously we can see frame relay topologies, partial mesh topologies, full mesh topologies, and hub and spoke topologies. So that point to point can be applied only to the hub and spoke topologies. Next, multi-point. In multi-point, sub interface acts like non-broadcast multi-access networks. So it does not resolve the split horizon issues. Split horizon issues means here we can see, here we can use multi-point. Multi-point means we can use only one IP address, that means 10.10.10.10/24 means here we can give 10.10.1, 10.10.10.2, 10.10.10.3 and 10.10.10.4. so here we can occur these split horizon issues. For example, if the packets can send to this router, means again that the split horizon issue means once the packet can be received that interface, means it does not send again through that same interface. So in multi-point we can use the common sub IP address only. So here we can occur the split horizon issue. Next, multi-point can save the address space because it uses a single subnet. In point to point we can use separate subnet for each network, but here we can use only single subnet for entire topologies. And multi-point is applicable to partial mesh and full mesh topologies. How to configure and frame relay point to point sub interface. Here we can see router A, router B and router C. This is an cloud. In cloud we have dozens of frame relay switches. So here this is a physical connection, serial 0/0. So the physical connection can be created into sub interface 0.110 and 0.120. Two sub interface can be created, and that IP address is 10.17.0.0 is an router A to router B, that is a separate network, and router A to router C is another separate network, 10.18.0.1. So here 10.17.0.1 is an IP address for router A and 17.0.2 is an router B. Here we can see del C value 110. So using that 110 del C, that indicates the permanent virtual connection between router A to router B, because this is in cloud. In cloud we have dozens of frame relay switches. We did not create then physical connection. Here we can create logical connection. So using del C value we can identify the logical connection between the router A and router B. So 110 indicates the connection between router A and router B, and 120 indicates the del C value indicates the connection between the router A to router C. Here we can see the configuration. So go to that router A. In router A, in serial 0, first of all we can change that encapsulation frame relay, that is HDLC protocol into frame relay protocol. We can change. Next, we can create the sub interface and indicates it is a point to point connection. Next, we can give the IP address and bandwidth, and here we can give frame relay interface del C 110, interface serial 0/120 and point to point connection, and frame relay interface del C 120. Configuring a frame relay multi-point sub interface. Here we can see router A, B, C and D. This is in cloud. In cloud we have dozens of frame relay switches. So here go to that interface serial 2.2. Here we can give 10.17.0.0. So in this whole topologies we can give that same IP address only, 10.17.0.1, 2, 3 and 4. Okay, here we can give the del C value to separate the permanent virtual connection. For example, 120 means it indicates router A to router B, 130 indicates the router A to router C, and 140 indicates the router A to router D. Here we can see the configuration. First of all, we can change the default WAN protocol into frame relay, encapsulation frame relay. Next, in that sub interface we can give the multipoint and assign the IP address. Here we can give the static frame relay map IP 10.17.0.2 is a destination IP address, and this is an del C value broadcast.